Hello students, welcome to the channel. Today in the Basics Explained series, we look at radians, which is an angle measure like degrees. So we discover, or rather we explore why we need radians, how are they related to degrees, and the kind of questions from radians that you are likely to see on SAT and ACT math. So the first question, why do we need radians when we already have degrees to measure angles? So let's answer this with the sine curve, right? So this is the sine curve. And if I were to plot the angles at which this curve moves, then I know that this is 0 degrees. I know that the sine curve touches a value of 1 at 90 degrees. It again becomes 0 at 180, goes to a value of -1 at 270 degrees, and finally comes back to 0 at 360, and this cycle repeats. So I noticed that I'm not using the same scale on the x-axis as I'm using on the y-axis, right? On the y-axis, I'm just using numbers, 1, -1. But on the x-axis, I'm using degrees, which are represented in steps of 90. For example, 90 degrees is 1, 180 is 0, and so on. So is there a better way to represent this graph where the x-axis can also just take numbers on the same scale as the y-axis? And that particular way is what we are going to look at when we look at radians. So let's move to that. So by definition, a radian is the angle subtended by an arc of the same length as the radius of a circle. So let me say that this is an arc length, and this is equal to the radius of the circle, then this angle is exactly 1 radian. What does that tell me? If I move through the entire circle, what will be the circumference? The circumference would be 2 pi r, right? And how many radians would that capture? That would capture 2 pi radians, right? Because if I move through the circle's entire length, then the arc length is 2 pi r. That divided by the radius is 2 pi radians. So an entire circle length is 2 pi radians, which, as we know, is equal to 360 degrees, because an entire circle angle is 360 degrees, which gives me pi radians as 180 degrees, right? Now, pi radians as 180 degrees is one of the most useful formulas that you would need in circles and in this topic, because this kind of gives you a method to convert any angle between degrees and radians, right? So let's try and write a few common values. So let's say this is the degree column and this is the radian column. So when I have 180 degrees, it's pi radians. So if I have 90 degrees, that would be pi by 2. If I have 60 degrees, that would be pi by 3 radians. If I have 30 degrees, that's pi by 6. 45 degrees, pi by 4. And 120 degrees, 2 pi by 3. So I can find any relationship, or rather any angle, and convert it between degrees and radians using this concept. Pi radians is 180 degrees. Now we come back to why we needed this. Now, if you look at the sine curve again, now let's try and write this in terms of radians. So 0 is 0. At 90 degrees, which is pi by 2 radians, it's 1. At 180 degrees, which is pi radians, it's 0 again. At 3 pi by 2 radians, which is, rather, let me write it on top. Yeah, at 3 pi by 2 radians, which is 270 degrees, it is -1. And at 2 pi radians, it's back to 0. And now I'm actually working with numbers. When I say pi, I actually mean 3.14 radians. And I can say that the sine of pi is equal to 0, right? When I say 2 pi, I mean 6.28. So I can say the sign of 2 pi is also 0. So here, these numbers on the x-axis are actual numbers that we can use rather than steps of 90 degrees as we were doing with degrees. So here I can have the same scale for the x-axis and the y-axis with radians. The number itself represents the angle. Okay, so then what is the kind of questions that you can see on SAT and ACT from this topic? So for example, this question, an angle with a measure of 7 pi by 6 radians has a degree measure of D, where D is between 0 and 360. What is the value of D? So I know that pi radians is 180 degrees. So 7 pi by 6 radians would be 7 by 6 into 180, right? I'm just using the same ratio. 7 pi by 6 radians would be 7 by 6 into 180. This cancels out, so that's 210 degrees. So D is 210, right? So conversion between radians and degrees is one question type. Another question, in the xy plane above, O is the center of the circle and the measure of angle AOB is pi by A radians. What is the value of A? So pause the video at this stage and try and solve this question on your own. And once you have an answer, come back and check if you got this right. This is a good question. So let's just draw this in a slightly bigger fashion. So this is O, this is B, this is A, and I'm told that the coordinates of A are √3, 1. So if I were to drop a perpendicular from A to the x-axis, then this distance would have to be √3, and this distance would have to be 1, because the x coordinate is √3 and the y coordinate is 1. So if I take angle AOB as alpha, then I can say that tan alpha is 1 by √3, right? Now on the first page of the test, the math cal and the no cal sections, you're given these two special triangles, right? You're given the 30, 60, 90 triangle, and you're given the 45, 45, 90 triangle, right? On the very first page where you're given instructions, these two figures are given. So in this case, the 30, 60, 90 triangle, the ratio of the sides are 1, √3 and 2, where 1 is opposite 30, √3 is opposite 60, and 2 is opposite 90. And in the 45, 45, the ratio of the sides are 1, 1, and √2. So with these, you can find any trigonometric ratio for these angles, right? So for example, I can see that tan 30 would be 1 by √3, which is what we have got for this angle AOB. So that means alpha is 30 degrees. Now, 30 degrees is how many radians? We know that pi radians is 180 degrees. To get 30, I divide this by 6, right? So I would need to divide pi by 6 also. So that's pi by 6 radians. Since we were asked the value of A, the value of A will be 6, right? So most questions of radians and degrees on the SAT and ACT are simple. They involve an understanding of the formula. Rather, you need to memorize the formula of pi radians being 180 degrees, and then you solve from there. Right, so if this was useful, let me know in the comments section. Hit like and subscribe to the channel. If there are other videos that you would like me to make in this series, let me know again in the comments section. I'll see you in a new video soon. Take care. Bye-bye.